Math 1314, Tyler Junior College, Section 1.5 Quadratic Equations, Video 8 of 10. In the previous video, we applied the completing the square technique to a generic quadratic equation, and eventually we got this as the solution. But I'm thinking if you're watching this video, or watching the previous video, if you watched the previous video, you probably saw the results and said, I recognize that. Isn't that the quadratic formula? And the answer is, of course it is. The quadratic formula, a lot of people think is just this equation over here. But the truth is, it's a conditional statement. If this, then that. The quadratic formula in its totality is if ax squared plus bx plus c equals 0 and a is not equal to 0, that would be back here, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There are rumors that you can sing this equation to the tune of Pop Goes the Weasel. Yes, you can. No, I won't. You're on YouTube, search it, and then regret searching it. Okay, so basically the quadratic formula says, I don't care if you can factor, I don't care if you can complete the square, I don't care if you remember how to solve using square roots. Give me 3 numbers, I'll chew them up and spit out the answers. So let's give it a try. For the first example, we're going to solve 9x squared equals 4x plus 2. Now, before you start saying a equals b equals and c equals and digging out the quadratic formula, you have to make sure that your equation is in the correct form. Something x squared, something x, constant term, equals 0. This is not equal to 0. That's an easy problem to fix. Remember, if you get an equation equal to 0, you have one of 2 choices. Empty out the left side and put everything on the right, or empty out the right side and put everything on the left. When solving a quadratic equation, I feel it's in your best interest to solve the version of the equation where the x squared term is positive. And since this x squared term is already positive, I'm going to leave it there, move everything else from the right to the left. Doing so will change each of those terms' signs. So the positive 4x will become negative 4x when we move it from the right to the left, and the positive 2 will become a negative 2 when we move it from the right to the left. Oh, by the way, factoring still works if it's an option. And personally, I prefer factoring because I can factor things pretty quickly when they factor and get my solutions really fast. But the quadratic formula doesn't care if you can factor or if the equation will even factor. It just says, feed me numbers, I'll spit out solutions. All right, so when you're pulling off the quadratic formula, at some level you need to identify A, B, and C. That can be mentally, verbally, or you can actually write it down. For example, in this problem, the A is the coefficient of the coefficient of the x squared. So A is 9. The b is the coefficient of the x, so b is negative 4, and the c is the constant term, which is negative 2. There's a mistake I see people make, so I'm going to tell you what not to do. There are some teachers that say, never tell them what not to do, because then they're going to see it and say, I'm going to do that. But I'm going to do it anyway, because some people do this and they need to be told not to. The a is the coefficient of the x squared, so it is just the 9. It is not 9x squared. I see people putting 9x squared here and here, and I cringe, because our goal is to solve for the x, not bury it inside the quadratic formula. Similarly, the b is negative 4, it is not negative 4x. So please leave the x's behind. The goal of the quadratic formula is to focus on the numbers and not the x's, or whatever the variable is. So let me get rid of this because it's in the way. Pull out the numbers, leave the x's behind. All right, now it's time to put them all into the quadratic formula. Now, There's a lot of ways to set up the quadratic formula, and there's a lot of ways to set it up incorrectly. One way to set it up correctly every single time is to write the formula without a single letter and not substituting the numerical values. So I'm going to recopy the quadratic formula, but every time I get to a letter, I'm going to replace it with an empty set of parentheses. So for example, instead of negative b, I'm going to write negative empty set of parentheses. Plus or minus, I'll draw the square root in a second. Instead of b squared, I'm going to put parentheses squared. And instead of minus 4ac, I'm going to put minus 4, empty parentheses, empty parentheses. And now I'll draw the square root because I know how large its radicand is. Radicand being the part under the square root. And downstairs in the denominator, instead of 2 times a, I'm going to put 2 times empty parentheses. By replacing each letter with empty parentheses, you're focusing more on the structure of the formula, and you're literally providing a place to put your values. Speaking of values, let's put them in. The a is 9. The a goes after the 2 and after the 4. So after the 2, I'm going to put 9, and after the 4, I'm going to put 9. The b is negative 4. The b goes at the beginning of the fraction and the beginning of the square root. So at the beginning of the fraction, I'm going to put negative 4 in the parentheses, and at the beginning of the square root, I'll also put negative 4 in the parentheses. The c is negative 2. The c goes at the end of the square root. So in this last parentheses, I'll put negative 2. Now, I may be making a big deal out of nothing. Some of you may be going, oh, I know how to put numbers into formulas, and that's great. But you'd be surprised how many times I see people kill their work at this juncture. They simply put the numbers in incorrectly. Don't be that person. I would rather you take more time and get it correct than rush through and sink it at the beginning of the problem. All right, so what happens next? Well, at this point, it's technically not an algebra problem anymore because there are no more variables. It's just a big arithmetic problem. But it's got everything you could ask for. It's got addition, subtraction, multiplication, division, squaring, and square roots. So where do we begin? Well, the answer to that is there's a lot of places you can begin. In fact, if you do one move at a time, this will take forever. Maybe not forever, but it'll take longer than it should. So my advice on executing the quadratic formula is to try to multitask. Look for as many places that you can do multiple moves at the same time. And there are 4 of them. The beginning of the fraction is a decision. Will it be positive or negative? The denominator is a pretty easy multiplication problem. Inside the square root, there's a subtraction problem, but on either side of it is a multiplication problem. On the left, in the form of an exponent, and on the right, in the form of a triple product, 4 times 9 times negative 2. But notice none of those moves interfere with each other, so it's okay to do them all simultaneously. But I'm not going to do the fraction, the plus, minus, the square root, or its subtraction yet, so those are still intact. At the beginning of the fraction, minus negative 4 is positive 4, and the denominator, 2 times 9 is 18. Under the square root, on the left side of the subtraction is negative 4 squared, which is 16. And on the right side of the subtraction, and this is where you have to be very focused, if you write the subtraction sign down, don't incorporate it in the multiplication problem. We'll deal with it in a moment. So on the right side of the subtraction sign is 4 times 9 times negative 2, which by the way is not a distributive property, it's just a long multiplication. 4 times 9 is 36. 36 times negative 2 is negative 72. And now that you've done all 4 multiplications, because technically you can view all 4 of these moves as multiplication moves, under the square root there's a subtraction problem that is waiting to be completed. It's currently a subtraction problem, but minus and negative will turn into an addition problem. And so we get x equals 4 plus or minus the square root of 16 plus 72 is 88. And that's all over 18. Now, we're not done, but every quadratic formula problem will act the same way until here. What I mean is you insert numbers, You clean up any double negatives here. It may stay negative. If this 4 were positive, then putting a minus on it would have made it negative. The multiplication down here is usually pretty easy. The squaring is pretty easy. The most common mistake at this juncture is making sure that you not only multiply this correctly, but don't get tripped up by the signs. Eventually, these two negatives made a positive, and you should forecast that before it happens, or foreshadow that, if you will. But every quadratic equation, quadratic formula problem works the same until you get here. And what happens next is 100% dependent on what this square root does or does not do. But the general rule of thumb at this point is to simplify the square root. Now that might mean that you flat out do it. For example, if this were the square root of 81, I would do it and call it a 9. And it also means you might not do anything to it. If this were the square root of 17, it would just sit there and not do a thing. And it also means that you may have imaginary numbers because you might square root a negative. But sometimes it means that you have to break it apart and do a piece of it. But once you simplify the square root, your next move is to try to do the plus minus, because sometimes you can and sometimes you can't, but you also have to think about simplifying the fraction. So basically, you just keep doing stuff until there's nothing left to do. I know I'm invading the territory for this problem, but that's okay. So let's move this up here. 4 plus or minus the square root of 88 over 18. And let's start by focusing on the square root. Now, there is a technique for figuring out how to simplify any square root of a whole number. For now, I'm just going to tell you that the best split for 88 is 4 times 11. No, it's not. 4 times 22. Because I know the square root of 4 and I don't know the square root of 22. So everything else stays the same. The square root of 4 is 2. And I don't know the square root of 22. Okay? Because we couldn't completely simplify the square root, we can't do the plus minus, so there's no need to take it apart. However, this fraction looks like it can be reduced, and we fought this battle before. We can reduce the fraction, but not across. You can't reduce parts of addition and subtraction problems. There's actually 2 ways to reduce this. One of them we've already seen. Split it into 2 fractions with the plus minus in between, and then reduce each one individually. But there's another way to reduce it without the need to split the 2 fractions, and that is to factor the numerator. Both halves of these can be divided by 2, so I'm going to factor a 2 out of the top. 2 goes into 4 twice, and if I factor the 2 off of the 2 square root of 22, I'm just left with the square root of 22. Now, what's the advantage to doing that? Well, what's the rule for reducing a fraction? You can only reduce parts of multiplication problems. By factoring the 2 out of the top, I've created a factor, a part of a multiplication problem, that can and will reduce with this 18. So that 2 goes into the 18 9 times, and we end up with 2 plus or minus the square root of 22 over 9, and that's as far as it goes. So when you use the quadratic formula, it's easy to start, but it's a mess to clean up. Now we've already gone 13 minutes, so I'm going to end this video in just a moment, and we'll look at not only this example, but one more in the next video. Yeah. I invite you to try to solve this one using the quadratic formula. I'll give you a hint. There's a lot of work you have to do up front before you even start using the quadratic formula.